Alright, one last topic to talk about. I'd like to talk about the slopes of parallel and perpendicular lines and why they're important when we're talking about quadrilaterals. So, what we've got right here in this graph is an orange line and a purple line that look like they're parallel, right? They look like they go on forever and they don't touch each other. And in fact, they are. One way that we can check that they're parallel is that they're going to have the same kind of slope, the same level of steepness, or the same angle right here. So if we check the slope using rise over run, we notice that this one, goes over 1 and up 2. Okay, so the slope of this line, the orange line, is rise is 2 and the run is 1. Okay, so the slope is 2 over 1 or just 2. Okay, if we check this line, we could pick any 2 points, remember, for slope. So maybe this line goes over 2 and up 4. So the slope is, 4 over 2, which simplifies to 2. Okay, good. So the slope is 2 for the orange line, 2 for the purple line, and so parallel slopes are always the same thing. Those are parallel slopes. Okay, so if someone says the slope of a line is 2, what's the slope of the parallel line? It'll also be 2. Always the same slope. If they give you 2 points and they ask you to find the slope of a parallel line, you'll find the slope of the first line, and then just use the same slope for the parallel line. Parallel lines have the same slope. Over here we've got perpendicular lines. And the first thing to remember is that perpendicular lines are lines that intersect at a 90-degree angle, a 90-degree or a right angle. Right? So, how do we know if 2 lines are perpendicular? Well, let's look at the slopes. So the slope of this green line, let's see. Let's pick this spot and maybe this spot. Those two points. Let's check the slope there. So to get from one to the other, I go down 2. That's my rise, negative 2. And I'm going over 4. So my slope for the green line seems to be negative 2 over 4, which simplifies to negative a half. This is my slope of the green line, negative a half. Okay? And the slope of the purple line, well, it's actually the same slope as we had before. We're going over 1, up 2. 1, 2. So my slope of the purple line is going to be, 2 over 1, or just 2. So then we look at these two slopes, negative 1 over 2, and 2, and we notice that there's some sort of pattern going on here. These are called opposite reciprocals, or sometimes negative reciprocals of each other. Opposite because the sign is different. This one's negative, this one's positive. And reciprocals because the fraction, the numerator and the denominator, the top and the bottom, are flipped upside down. Okay? So it kind of doesn't look like it with this 2 here, but remember the 2 was the same thing as 2 over 1. So negative a half and 2, or 2 over 1, are opposite reciprocals of each other, right? We flip the fraction over and we change the sign. Sometimes we call that keep, flip, change, KFC is a way to remember that, but they're technically called opposite reciprocals. And so perpendicular, P-E-R-P-E-N-D-I-C-U-L-A-R, perpendicular lines have that opposite reciprocal slope, or the keep, flip, change slope, whereas parallel lines have the same slope. Now why does that matter when we're putting shapes on a coordinate grid? Well, here you've got a shape. It looks kind of like a rectangle, but how do we know it's a rectangle? Okay. One way to check is check out what these angles are, and whether the top and the bottom and the two sides are parallel to each other. Well, we can check to see if there's a 90-degree angle here by seeing if these two lines are perpendicular to each other. So how do we figure out if lines are parallel and perpendicular? How do we do that? Well, the answer is slope. We've got to check the slopes. So let's check out the slope for all 4 sides. So we'll call this A, B, C, and D. So the slope from A to B, up 1, over 1. The slope is 1. 1 over 1. 1 over 1, which simplifies to just 1. Okay. From B to C, down 1, over 1. So down 1, negative 1, over 1, which is just negative 1. So the slope is negative 1 there. from C to D, let's see, we're going over 1, up 1. So slope from D to C is 1 over 1, or just 1. And the slope from A to D, we've got to go down 1 over 1. So down 1 over 1. So our slope is negative 1 over 1, or just negative 1. Negative 1. So just so we can see, let's put those slopes in orange. Okay, the slope here was 1, negative 1, 1, negative 1. Okay, well right off the bat we can tell that the two negative ones, that's the same slope, which means those two sides are parallel. Okay, parallel. Again, these two sides both have a slope of 1, which means those are parallel. But what about the right angles? It doesn't really look like these are that opposite reciprocal key flip change or perpendicular slope, but really they are. Remember, 1 is the same as 1 over 1. Negative 1 is the same as negative 1 over 1. Okay? And if we switched the top and the bottom, the numerator and the denominator here, and change the sign, okay, just like we did up here, we would get negative 1 over 1. Okay, the same thing we had before. So in fact, these lines are perpendicular to each other, which means that we can use green. We can put in those right angles. Okay? And now we know it's got right angles, it's got parallel sides, that is definitely a rectangle. Now we've proven it's a rectangle using slope. You can also do things with distance to check if the sides are congruent, but for a rectangle we don't technically need that. You'll need it for things like a rhombus, a square, an isosceles trapezoid, or a kite. And in that case you want to find the distances in addition to the slopes between each of the 4 points to see if the sides were congruent. But for a rectangle we just need the slopes. Hope you've learned a little bit about parallel and perpendicular lines and slopes here, and good luck on your work.